force. That is chapter 3. Now, we have to start by looking at the main objective of this topic, right?
Yes.
So the main objective here, that by the end of the topic, you should be able to define what is moment of a force about a point and state it as a unit. Are you together?
Yes.
Then you should also be able to state and verify the principle of moments, and again you should be able to solve the problem involving the moments, the principle of moments, right?
Yes.
So those are key area that you should be able to be aware about. Now we have the moment of force. There we go. So the moment of force, as per the definition, it refers to the turning effect of a force, right? The turning effect of a force. So that's the moment of force. So how do I calculate the moment of force? From the definition, moment of force is basically the force times the perpendicular distance from the line of support, right?
Yes.
So how do I calculate that the moment of force? Then I'll be able to have the force and the distance which is perpendicular from the line of support, right?
Yes.
So from the definition, now we are able to identify what is the SI unit. So can someone tell us what is the SI unit from the definition? Yes, Atul. Newton meter. How did you get Newton meter? How did you get Newton meter to be the SI unit? Yes?
Force which is SI unit is Newton is particular to the perpendicular distance as its SI unit is meters.
Good. So that is it. From the definition that we can get that moment of force, we can calculate it as force times the perpendicular distance. Then it simply means that the SI unit of moment of force is Newton meter. So therefore, if you are given in centimeters, what will you do? Yes. You're going to convert from centimeter to meters because the SI unit talk about Newton meter. So let us look at examples where we have activities where we have moments of force. So one of the activity is opening and closing a door, right?
Yes.
What we do on a daily basis. So remember, physics is all about life. So physics all about life. So one of the activity is opening and closing a door, closing a lid of container, and having a pair of scissors and garden shear in you of moment. So another one is tightening a screw. Look at those two. There's a boy there and a girl. So what is happening? We have a seesaw, right?
Yes.
So something is happening. There's a turning effect. So when the boy goes, the boy has a force of 500 Newton and the distance is 2 meters. Let's go there a little bit and see it. The force of the boy is 500 Newton, right?
Yes.
And the distance from the point of support is 2 meters. Can someone tell us from the definition of what we have talked about, what will be the moment of force of the ball? What will be the moment of force? One somebody else. Yes? 1,000 Newton meter. How do you get 1,000 Newton meter? Yes, force times the distance from the point of support. So you are able to see that this is our point of support, and the force is 500 Newton, right? And it is perpendicular. So the moment of force acting this side will be this force 500 Newton times 2 meter. We get 1,000. So that's the moment of force this side, right?
Yes.
So the girl, how are we going to get the moment of force of the girl? First, we have to know the weight of the girl and also the distance from the line of support. And our line of support here is this fulcrum, right?
Yes.
So that is what happens. Now, like the girl, we have 1,000 Newton and 1 meter, right? They are balancing each other. So look at what happens. So if the force is less and the distance is higher, so we are going to find that for it to balance, then the force of this the other side, the girl, must be higher and the distance must be less. So in other words, we are talking about the factors that affect moment of force. The factors, right?
Yes.
So from the definition, we can get the factors that affect moment of force. We have two of them. One is amount of force, right?
Yes.
So look at this one here. So for it to remain in a state of balance, look at the force here is 1,000 Newton, but this side is 500 Newton. The distance decreases while the force increases. Are you getting the point?
Yes.
This side, the distance increases while the force decreases, right? So we have two factors that affect moment of force. That is force, amount of force, and what? The distance from the line of support. And that distance must be what? Perpendicular, right?
Yes.